For more than a century, fossil fuels like coal, oil, and natural gas have powered our world. They fueled factories, lit up cities, and made global travel possible. But this heavy dependence has come with a price: carbon emissions, global warming, air pollution, and resource depletion. Now the world faces a defining question: what will the future of fuel look like? Today, oil and gas still supply around 80% of global energy demand. But things are changing. Many countries have committed to reaching net zero emissions by 2050. Investments in renewable energy like solar and wind are breaking records, and the transportation sector, responsible for more than a quarter of global emissions, is under growing pressure to transform. Future alternatives: hydrogen. One of the most promising fuels is green hydrogen. It is produced by splitting water using electricity from renewable sources. Its biggest advantage? The only emission is water vapor. Hydrogen could power heavy transport like trucks and trains, decarbonize industries like steel and cement, and serve as long-term energy storage. Biofuels. Another option is biofuel, created from plants, used oils, and agricultural waste. It can be blended with conventional fuels or used directly. Airlines have already begun trial flights using sustainable biofuels. Synthetic fuels, e-fuels. Synthetic fuels are produced by capturing carbon dioxide from the air and combining it with hydrogen. The result is a liquid fuel that can be used in today's cars, ships, and airplanes with little modification. Companies like Porsche and Airbus are investing heavily in this technology. Electricity as fuel and, of course, electricity itself is becoming a dominant energy carrier. Electric vehicles are already transforming the automotive industry. The main challenge lies in battery storage for long-distance transport and aviation, but progress is advancing rapidly. Real world examples: Germany has launched massive projects to develop green hydrogen and sees it as a cornerstone of its future energy system. Japan is building a nationwide hydrogen economy, powering both homes and vehicles. Saudi Arabia is investing billions in the NEOM project, one of the world's largest green hydrogen plants. Airlines worldwide are testing sustainable aviation fuels in a bid to reduce emissions from one of the hardest to decarbonize sectors. Challenges ahead. The transition is not simple. Green hydrogen and synthetic fuels are still expensive compared to fossil fuels. Infrastructure is limited. There are not enough hydrogen refueling stations, pipelines, or large-scale storage systems. Competition is also fierce. Will the future belong to electric batteries, hydrogen, or a mix of both? And finally, politics and economics will play a critical role. Government policies, subsidies, and international cooperation will determine how fast the world can transition. Conclusion: the future of fuel will not be built on a single source. Instead, it will be a smart combination: hydrogen for industries and heavy transport, electricity for everyday vehicles and homes, biofuels and synthetic fuels for aviation and shipping. This transformation will not happen overnight, but it has already begun. Engineers and scientists are shaping a new energy landscape, one where fuel is cleaner, smarter, and more sustainable than ever before. The only question that remains is, are we ready for the energy revolution ahead?